So we're not really showing sort of products today. We rather want to have a conversation about what is in that whole realm of AI and platform engineering. What has substance? What is very early on? What are we observing? I'm just returning from Next, for instance, Google Next, and I'm like full of the incredible stuff that the Google guys have just launched. And so very important, very interesting time here. Now I'm joining this meeting a second time, which is also great. And that's really what we want to do today. Sylvain, like we've been going back and forth on you're building something, and maybe you can explain us what Rootly Labs is doing, and then we're doing stuff. And I just want to have a ping pong between all of you and us. Where are we? What is already ready for the enterprise? How do we think about designing these things in a way that we can use this? And I think what we have in common that we work at comparably large scale, right? So that would be great to hear what your target audience is, but we usually work with very large organizations with very serious security teams. And if I come in and say like, guys, this works in 70% of cases, they'll say like, this is really nice. There's the door. So that won't cut it. Maybe we start there. What's like, where are you coming from? What's the situation on the ground at Rootly? What you're doing? What are you doing with Rootly Labs?
Absolutely. So I come from a software engineering background. I spent 15 years in Silicon Valley working for startups like SlideShare and large companies like LinkedIn. I was a senior SRE there. So I've been on the field. Now I'm the head of developer relation at Rootly, and I'm heading the Rootly AI Labs. Rootly is an on-call and incident management platform. So basically, when your production breaks, SRE teams need to handle the incident, and they go to Rootly to orchestrate the incident response. Now, in terms of AI, Rootly is already using a lot of AI features, and more specifically LLM, for things like, hey, like we can ingest all the data that's being shared on Slack and on a Zoom call related to an incident. And so when someone joins an incident and wants to be briefed, instead of a human who should be working on solving the incident, briefing this person, you can have a chatbot doing that. Another example is if you want to write a postmortem, no one likes to do this. LLMs are great at coming up with a draft based on all the context that was ingested. Now, the second thing that we are building, and is still very much work in progress, like Kenyon, is an AI SRE. So as of now, Rootly is doing incident management, but we are not directly helping with incident resolution. And because all the data related to an incident is flowing through your incident management platform like Rootly, we have a lot of context about what's happening, what happened in the past with former incidents. And if you feed all of this to an LLM, we can certainly come up with suggesting what might be the root cause of the issue and suggesting a fix. Now, the last thing that we are doing with Rootly is the Rootly AI Labs, which I'm the head of. It's not part of the Rootly engineering organization. It's its own thing. It's a community-based initiative where we build open source prototype leveraging the latest AI trends, which we are going to discuss today. We have researchers, we have like big names in the engineering industry. We have the head of platform engineering at Venmo, the former head of AI at Twilio, and think of it as a large hackathon that's constantly happening, and which is where the MCP server, which Humanitech is using now, came from. And last but not least, Caspar, to look back on what you mentioned in terms of customers, we serve small customers, but we also serve large enterprise like NVIDIA, LinkedIn, Brex, Canva, Cisco. So we also have to deal with enterprise where, as you said, reliability is very important. And AI, I think, has a lot of issues with reliability. And I guess that's also what we are going to speak about today.
Absolutely. Cool. So if you already gave us a little bit of a hint, I know that there are a ton of people that are also really want to get their hands dirty and understand how much buzz and how much reality is there if it comes to agents. When you've built this from a technology point of view, how have you approached this? What are you using?
For which product do you want me to answer?
For the yeah, I mean, like for either, like if somebody wants to you know, you already have a service, you would just want to make this consumable, what would you use? And if you want to make this more agentic, what would be the what are interesting technologies that everybody in this call should definitely look at if they want to skill themselves up?
Yeah, I think the latest, not no longer latest, but almost latest is MCP, which is a protocol that was pioneered by Anthropic. And MCP is streamlining communication between an AI agent. This AI agent can be on anything. It could be in your browser, it could be in an existing application. More commonly nowadays, it's an agent that's living in an IDE, LLM power IDE. And what this protocol does is that it streamlines communication between this agent and a data source, which is most of the time a REST API. Now you're like, wait a second, like LLM can already query REST API. Yes, but REST APIs haven't been designed with AI agent in mind. They are one-to-one, like it's an isolated call, like there is no context sharing. It's also designed by human for humans. And so when an agent is using a REST API, it can work, but sometimes it cannot work because maybe you need to do multiple calls. Maybe the agent doesn't understand the business logic behind the flow. And so you may end up with an answer that's not accurate or completely wrong. And so MCP is really streamlining this. So think of it as like the USB protocol. You had a bunch of protocol before USB for data transfer, but they were not as good, right? So MCP is an evolution of this.
Nice. Okay, cool. So this is what you're really using to essentially um, allow agents to consume your API and give the agent the context of what will happen if they make certain calls, correct?
Yeah, I think you hit the nail on the head. The word context here is the key. Um, LLMs have been like impressive on so many layers, but what was missing is that they were behind the gate, right? They were isolated in their environment, and not really able to interact with the outside world. With MCP now, and by the way, MCP was pioneered by Anthropic, but it started to be widely adopted, including by their competition, OpenAI. So I think
Yeah.
that tells a lot about, right, how promising is the protocol. And as you said, it can bring context within your agent. And with this context, you can do just amazing things.
Yeah. And the I mean, I also agree, like from I think all the data we're seeing right now, it looks like MCP is coming out on top. If can you maybe from the we had a conversation. Google just announced this agent-to-agent framework. Can you maybe explain us a little bit how these things relate to each other?
Yeah.
To me
So yeah,
also?
yeah. In terms of protocol for MCP, which is again agent to data source, you have two of them. You have MCP, which is the one everybody knows about, and IBM came up with one which is called ACP. It's the exact same thing, but just one letter off, and it's a competing protocol. I haven't seen anyone adopting it, but it's there. And for each new like technical evolution, like you have a war for protocol. So this is happening. Now you have a second protocol, which is agent to agent, A2A, short, that was pioneered by Google. And this protocol is complementary to MCP because it takes part of the communication between agents. So again, MCP is communicating with data sources, and A2A is handling the communication between agents. So they are complementary. If we take the example, if we take a non-technical example, let's say I want to plan a vacation in Germany, and I have a budget, and maybe I want warm weather, right? So that's my request. If I send this to an LLM power platform, it will need to tap into multiple type of sources, such as the weather, the type of activities that you can do in the location, flights, hotel. Each of this is a different data source. And so for each of this, you will have an MCP server doing the communication. Now, the user wants, they just have this request. And so A2A will take this request and will be the one that's calling this MCP server, making sure that what they return makes sense, and then return a well-formed answer to the user.
Yeah, so this is definitely like a whole new, like a whole world of stuff that we'll have to deal with. In general, like if you are working across several MCPs, MCP orchestration is another thing, right? Like how do you make sure that the system that the user interacts with will hit the right MCP at the right point in time? Like a whole issue. Okay, cool. Let's get a little more concrete. So I mean, I'll just introduce Kenyon a little bit, and then we can chat about this. So I was to out myself, I was on the skeptics front for a long time. I'm going for a walk with my father every Sunday, and my father is a theoretical physicist. And so he was like, when LLMs came, he was like blown away, and I thought like, this guy, I had no idea. Because I always thought, like this degree of hallucination. I was surrounded by, principal engineers, and they all said like, yeah, no, we're not using it. Like, it's not accurate enough. It's the wrong technology. And we all tried Cursor, we all tried Warp, and the 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 people that were not that principled, they all said like, oh yeah, amazing, like I can code faster. I observed that the really principled guys said like, oh, like, so, like I'm so much faster if I do it the way I'm doing it right now. And so I was very influenced by this and said like, okay. Now, then I think this skepticism is something that a lot of people, especially in our industry, have. Like I've been surprised how lukewarm the reception is at times. Now, one of those, we go on walks like for months, and like he's always like amazing, and like he started a whole stream of lectures at his university only about artificial intelligence, and super in love. Now, I always didn't really understand. I was talking against him, and then he said, like, look, 15 years ago, we would do complex metrics, trying to find local global maxima in complex metrics calculations. And we had vector spaces that were weighted, and our core problem is that we always ended up in a local maximum and not in a global, right? And this LLM space is not so different, right? It's very like you get an input vector, you have a very complex matrix calculation that is trying to identify a maximum, and if it hallucinates, it's actually hit a local maximum. But we've solved this problem 15 years ago for most of the physics applications. It is very unlikely that they're not going to solve this for LLMs. So this is almost certainly going to stick, and you are wrong. So then, I speak with more people. I look at some of the statistics. I think I can't name the name, but it was for the first time I talked with an enterprise CTO who said, like, yeah, my guys are going into Figma. They are changing a couple things in the design, and we are talking about a large application that all of you use at least once a month. And then we have an AI that is just identifying the component libraries, putting everything together. We run tests for 15 minutes, we ship to production. That guy is no nonsense. Like he would never do this. I remember how he evaluated blockchain and said after 3 days, very cute, but not on my watch. So I said, okay, like you are probably wrong. And then also very interesting to be in San Francisco, in Las Vegas last time. And usually I don't really like these conferences, but this time it was so all of those Google people developing stuff, and I can see how they're now starting to develop something, then you have one model checking the other. The supply chain is more and more actually optimized. You have checks for hallucinations, you have checks for quality assurance. I can see that the whole platform architecture has to change because the front runner teams are actually tuning their toolchain in a way to catch these things very early on. Now, then another thing that influenced me a lot is this cursor tap, tap, tap idea, Cursor with this idea of proposing the next 5 seconds, so to speak, and the human in the loop just says, okay, I accept, 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 no, and which gives this very nice security gate. And then also one of the things that this enterprise CTO said, if you have models that are trained on a very large amount of data, which those LLMs are, but then you let them work against a finite space, then they perform actually really well. So what I mean by this, when I spoke with the companies that are generating infrastructure as code, right? There are a few companies that are doing IAC generation. They always said, like, we've been testing this for so long, we're not able to get this beyond a 90% accuracy, even if we train on a specific estate, which is obviously not enough. So that was one of the big drivers of my suspicion. But if you look at this is not a very confined space. From a combinatoric point of view, there are millions of options of how to combine tuning parameters in RDS, right? You can do a lot of things. But if you confine the space of options and make it finite that the model can choose from, then we found, okay, that's actually getting pretty accurate. So that's why the approach that we have with Kenyon is to say human in the loop. So you decide who taps, and a second you let it you let it argue and decide on a finite set of things it can do. And then we thought, okay, what's the finite set of things that would help people in platform engineering? And then my idea was, okay, golden paths is probably that, right? Platform engineering is more or less about what is repeatable. Now let's build a path that you can use over and over and again. And then we said, okay, if we have a concrete object that is a path and you can design the path however you want, then we could essentially make it the model's job to propose the right path, and then the human's job to confirm whether the path is configured and selected the right way. Now, then there is a thing that comes in that makes it super difficult to act on estates if you just act on the raw data. And that is that you have no way of actually understanding, or it becomes very overwhelming to understand how things actually fit together and what your downstream dependencies are. So my simplest example is you have an Apple service and you have that 3 times because you have it in dev staging and production. It's super hard for the model to actually act on the data fast and say, this is probably production. So you need to have some sort of tagging mechanism, and you need to have a graph of your estate. And I just saw that at Google, they've come to the same conclusion. I mean, I've demoed to them a year ago, and now they are at the same conclusions. I hope this doesn't have too much to do with each other. But they now, in this app hub thing, have a complete representation of the graph, and all of the AI actually acts on the graph representation. So you need to have a very consistent metadata model in your platform to actually let AI act on this. So we said, okay, that means we can't let the model act on the raw data. We can't just import everything from all the systems, but we have to structure the system first. So we need to have an orchestration system. So for now, we've used Humanitec's platform orchestrator, but we're building a new version of an orchestration that is a lot less intrusive and much easier to onboard to. Yeah, so that is, I mean, the Humanitec orchestrator has another job is way more secure and structure focused. But this one is really about giving clarity to your state. Yeah. So this was sort of the thought process in designing this. Sivan, how are you solving the hallucination? Like what are your thoughts on this?
Mhm. Well, first of all, I mean, I also feel the skepticism, and I think it's, we should be skeptic, especially when you are in the world of reliability. That's our job, to make sure that things stay stable, and we should be skeptic of anything that could make it unstable. But I would argue that humans are also not reliable, and that's why we have all this um, process in place to ensure that um, an issue, a mistake, an instability is not introduced by a human. And I think it's the exact same for LLMs. And so we should not think that LLMs are God or the silver bullet or they know it all. They provide some value, they make mistakes. We should apply the same degree of skepticism as we do for humans, and then see it as just another coworker that can make mistake. Now, how do we deal with hallucination? Actually, it's interesting because we spoke a little bit about this with A2A, but the way we structure our product is that we have an agent orchestrating other agent, and this agent is not only deciding that like the overall roadmap and what we should achieve, but also in charge of making sure that what the sub agent return makes sense. And this master agent, if I may say, act as a way to remove any hallucination that sub agent would do. So it's a little bit like having, as you said, like a human reviewing and making sure that what the LLM suggests, but we automated this with an LLM. And ultimately, I think the adoption of any LLM-powered software will come in phases. And so if we look at what we are building at Rootly, which is about investigating an incident and then telling you how to solve it, just consuming the RCA, the root cause analysis, is harmless, even if it's wrong, right? And what we
Yeah.
do is that we show a degree of certainty. So if it's 99% certain that this is the issue because we saw that a commit just happened on your repository and there is a mistake, a typo, whatever it is, it's highly certain. If it's an external factor, then you are getting DDoS or there is instability with one of your service provider, then the degree of certainty may be lower. And so here humans have to, consume thing based on that. And then the next step is to empower your system to act on your behalf and push something to production. And here I think we should apply the same set of roles like canary deploy, push to staging, and monitor how things are going. So that's our approach, and we believe it's solid. And we are working with design partner, and I think so far we've had very positive feedback.
And the feedback from the design partners is that okay, so but that means you essentially have predominantly query actions at the moment. You're not doing edit actions yet.
We are not doing edit action yet. That's correct. For now, we are only doing RCA, which is a root cause analysis. But once you know the problem, like coming up with a solution is fairly easy. So
Yeah.
that's the next item on our roadmap, but we haven't implemented this yet. And I think for our customer for now, I think they want to do RCA, root cause analysis, and have it as like a passive part of your team. I think the one where the agent is actually changing, like, impacting your production is the next step. But I think you need a degree of confidence that comes with time.
Yeah. 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 Cool. All right. I think it might make sense that we get a little more tangible and show a few things here. So I've fired up a very rudimentary system here. Like, it's actually interesting because You can build a lot of that yourself. It'll take a while, but you'll learn a lot. So in this case, we've tried a couple different implementations. We've tried. We have just let me share my screen properly. So we have a 320. Yeah, we have like a just a chat that you can UI that you can reach. We've tested this with Teams and Slack, and then we have used this as in IDE plugin. I mean, there's so many. It's such a rich ecosystem already. It's insane how fast this is developing. So in this case here, we're just using Klein. Klein is an MCP management plugin maybe for Visual Studio Code. So you can really just download this. And if you look at the here, then what we essentially have is we have Kenyon here. We are using Gemini because it is just so insanely fast and accurate. We first used the Anthropic Claude 3.7 model, which is accurate but very slow. That for me changed a lot when the models became so fast, which was 2 weeks ago. And then we use an orchestration in the back end because we just continue to think that execution has to still remain very deterministic. The orchestration catches paths and infrastructure templates, etc., from GitHub, and then we're using a GCP setup here behind. So again, this what we're going to change this. So Kenyon will get its own orchestration system that can read in and then actually act on estates. Here, if you and so then let's have a look here. So I can really just ask you questions. Hey, Kenyon, could you please, and I'm always trying to be polite with models, then somehow they work better. Could you please generate a force-directed graph of my environments, apps and environments in... Okay, and then what this will do, it will just call the paths, and I honestly just usually put this on auto approve and don't like for all query actions. And it's pretty good now at actually detecting, is this a query or is this a substantial action? So I'll just leave it to that also because it's a test setup. And yeah, so here you can see now it's actually giving me like a whole force directed graph of all of the different applications in my universe that I have access to. And that's also important. So the way we've designed this is pretty obvious, but just to make sure this is clear, that the developer requests the path, this gets forwarded, the path gets proposed, and then we assume the user's role-based access control. So what you're seeing here, and you can't see it, but let me zoom in, you see an actual application. So we were speaking at the Brazil Platform Days 2025, as you can clearly see 2 hours ago. And so we scaffolded an application there. And so this is now part of this. You can see already metadata, deployments, links. You can go into the environment. And what I find interesting is that those UIs are now depending on I can also, search this, obviously, show me all production environments, etc. So that those links are now, or those UIs are being rendered depending on what I ask. So if I would go back and say, okay, show me the same, including all resources and services, it would essentially show me the next level as well. And I can obviously say, okay, nice, show me this as a tree view. Or I could say, okay, I now want to see all latest deployments and I want to see the diff between the deployment and actually see what happened. And that would do that as well. So, okay, now it's showing me actually this, and by this setup here, and this is state is growing a little large for a demo. Okay, so yeah, so this is pretty straightforward. And then we have things that we can do. You can see that it's detecting the right path. So if I disable auto approve for a second, and I go ahead and I say, can you explain to me in detail what paths are already configured in Kenyon? And then it will essentially call that and surface those objects and explain that to me. So we have configured adding a Postgres database. We've configured promoting to the next environment. We've created ephemeral environments. We've configured granting view access to something I don't have view access for. So access management and creating application. And those paths are written as code and always then executed through orchestration and pipelines. Now, what I think is cool is that you can also use existing pipelines or backstage stuff that you have already and get that in here. Yeah, so this is pretty neat, and that you can obviously then bring this together. So I could, for instance, say, let's create an application together. What do I need to do for this? And to create an application, you need to provide a unique application ID. Okay, so we call this webinar spring night beautiful weather, because it's spring in Germany. That's one of the very few times in the year where we enjoy living in Germany. So we approve this, and you can see that it's hit the right path here, and it's used the right variables, everything fine. And you can also see how fast it is. That's the thing that I really like, blows my mind. That made such a difference. In Claude, I think we needed like 7, 8, 9, 10 seconds for every request. Here we are using Gemini 2.0 Flash, which is super fast, maybe a little less accurate, but so fast that it's definitely faster than anything I could possibly do in my even opening a UI, going in. If I now prepare for a sales call, for instance, I'll go in, I'll have the model or the agent get me all the stuff, consolidate this, prepare me. It's so much faster than if I would go to HubSpot, then I need to authenticate, then I need to go into this system and this system. So that's pretty cool. Yeah, so now this is running and it's created webinar spring beautiful weather. Everybody's happy. And now I can say, okay, nice. Can you show me this as a graph, please? And you guess what will happen now. It will now show us all of the components. And we can then actually go ahead and we can git clone this and start coding. This is including now a namespace and everything set up end to end, and I'm able to go ahead. I'm not going to do this because you saw this already. Last thing I wanted to show you is I do not want to proceed. It's also getting much better. We're currently testing with that on proposing the next best action, even as a selector. But yeah, for now, last thing that I maybe want to show is such a scene of something that like I'm using this to understand what's going on, and this is now working across several MCP servers. If I, for instance, say, okay, Sylvain just called me and felt very sad. It looks like the Apple service is super slow. Is there an incident? And if so, is there maybe a ticket associated? And so then we can actually see how good it's doing and actually understanding which system it should call. So here you can see it immediately said, okay, this should be Rootly, and it will now call Sylvain's beautiful MCP server, and it will then return a list. And in this concrete case, it looks like there was an error. But this might me. So now it's asking this. So this is interesting. Now it's going on a detour. It shouldn't do this. Do you recognize the error code? No. So this is still very, very raw here. Let's try to find the incident in Rootly that might be to the Apple service. So let's see. It's searching Rootly. Okay, now it's got it. Not sure what the glitch was there, but that's I think what I meant. There's something wrong here. Not sure what this is about. But this is, I think, what I meant. It's becoming very, very quickly at even if you would need to do a detour, it was super annoying. Yeah. So now it found this in Rootly. That's great, and now it's searching my ticketing system, in this case Jira. And this has been super annoying if you had to wait for models a long time. Like if every single click that I would have done would have taken 10 seconds, I would have been so annoyed that, we would be, I would have just said, okay, whatever. But now even it had to take a few detours, but then it found, okay, there's an incident related to the Apple service, there's a bug in Rootly, and there's an associated ticket, and so everything is fine. Okay, is there any context in the ticket that might help me resolve this incident? And then again, it can do that query and figure out more context on this. And once I have this, I pushed a fix. It looks like somebody in this ticket says, I pushed a fix to development. Then my house caught fire. Can somebody promote this? Okay, it's like, okay. And then I can say, okay, where in my estate is this? And I can say, can you list all services of the project Abracadabra? Is the Apple service part of this? And I've tested this. I could have just ask it in general to do these things. And then I wanted to show you this now step by step, but it would have actually gone ahead and it would have made a plan for itself. I can show you like another test that I did, and it would have queried all of those systems and it would come up with the same answer. And now you can see it searching this. You can see it asked the documentation because it wasn't sure. And now it's hit the right path and it found out that the last deployment set ID for this one is this here. And now let's see whether there is an Apple service and this is actually the case. Perfect. Now give me the state of deployment of the Apple service across all environments. And now it will do that. And that should be super fast. And boom, here we go. So it looks like development is here and production is here. And then I can say, okay, nice. Let's deploy, let's promote the state in dev to the state in production. And then I can go ahead. And in this case, it would say you don't have the authorization. So I will send a message to the owner of this and ask it whether the owner is okay with this pipeline functionality. The owner will say, okay, let's go. And then it will resolve this for me. Yeah, so you could see in this case, it did in comparison to I use this tool a lot, did 2-3 detours, but it doesn't really matter because it's able to find the right path so fast, and it's able to resolve this, and it's identifying the path. So we're testing this regularly. It's identifying the path with a very, very high accuracy, and that's what I meant. That's also because the total sum is finite, right? We're not talking about millions of options. We're talking about hundreds of options. Yeah. So, Sylvain, what went through your mind?
Yeah, I think one interesting bits that we could share with people who are with us today is that there is I think it's important actually to speak about context size, and especially when it comes to MCP. Actually, as of now, you cannot add an unlimited number of MCP server to your AI agent and hoping for it to work. Like the agent are kind of getting lost if you provide too many MCPs server. So there is like here like something to improve with the protocol, which I believe A2A might be able to solve. And I think what you showed here is like exactly like the type of workflow that I think platform engineering teams or incident response team can leverage. And some action may be faster. Some of this, maybe, hey, I can do this faster than other. In our specific case, what we say is that, hey, let's say you are getting paged at 4 in the morning, and you were like in the middle of a deep sleep, and you are like having like a mini panic attack because your body is like, what's going on? Having someone who can do such advanced reasoning and pull data from multiple sources. In your example, you pull from Rootly, from was it at Jira ticket system, and maybe from GitHub, right? And like this is so valuable, right? Um, so again, I think like people should approach this with like it's gonna augment me, it's not gonna replace me. As you said, like keeping the human in the loop is like absolutely necessary, at least as of today. But I think your demo demonstrated how powerful this tool can be, and that's only the beginning, right? It's only gonna get better from there. Um, Actually, a very small detail on the not on the models. We recently did a benchmark out of the AI labs to benchmark model again coding task, and Gemini 2.0 Flash did very well indeed, on par with GPT-4o. But we found that Llama 4 from Meta was kind of a no-go. So there is also an interesting battle in the model space where um, it's moving very quickly. And so I like the fact that tried something else than Anthropic, which is, I think again, also in terms of accuracy, seen as the leader. But it's moving very fast. And so it's good for companies like Humanitech and us to like be experimenting for the community. We may not have the time, to play with all these models.
Yeah, 100%. I think there's also there's a open question from David. What's even more troubling is that the reasons LLM give for their conclusions are disconnected from what is actually happening. They produce a creative reason, but not the actual one. Yeah, I think this here showed this. Like if you so this is, first of all, I think again it's a question of how are you setting these things up and to catch hallucinations. There is an incredible amount of innovation coming. You can just increase the compute power to let agents check itself, essentially investing more money in becoming more accurate. And this human in the loop element is just so insanely important. Like, I'm just 100% with Savin. For the query situation, retrieving data from a confined set of data sources, I am at this point very sure that this is going to replace most or many interaction forms. If you know exactly what you know and you're a power user, you'll use a CLI. Sure, very deterministic, boom. But if I'm a power user and I need to go to a user interface, and then I also look at disintegrated data. Like if you're looking at a CRM or you're looking at a ticketing system, it's 98% is toil. It is information that I do not need. I want this one condensed thing. Now I want to just have a condensation of everything that's going on. This thing at the model speed that it's now, at the latency it is now, in my daily workflow now beats every single attempt to try to go to a UI. The only time I do this is I say, okay, let me look at my to-do list so I get inspiration of what to do next. okay, sure, then it makes sense. Or I need to write a document. But other than that, I've rarely been so convinced of an interface for platforms than the conversational things. And after the chat ops days, 2015 and onwards, I thought, when that went away, I thought, okay, we'll never again have this. We are de facto going back to chat ops, right? It's crazy. Okay, so Sevan, what's next for you? Like, how are what will you be working on in the next? I mean, we can only talk about weeks at this point here, so because everything is so fast. What are you focusing on next?
Yeah, so I think the next big thing is, I think similarly to Kenyon, we want to release like a production version of our product for the AI SRE. For the AI lab, we want to actually, there is one initiative that we are trying to push and to make it a community-led initiative, even outside of Rootly AI lab. We want to come up with a benchmark that is specific to SRE or system administration, or basically our space. There is a lot of benchmark for mathematics and coding, but I think for everything that's infrastructure and platform, there is yet something to come. So that's something that we are focusing on. And basically, what we want to answer is basically what you just mentioned today is like, hey, we used to use Anthropic, but now we find out that Gemini is the best. Is there a way that we could quantify this using benchmarks so you know exactly which model to use for your product and your application? So that's a project that we've been working on and that we are pushing. We are in conversation with Microsoft Research that is also leading some work in this space. So if you are interested in being part of the project or conversation, please let us know. And then for us, it's really about building tools that the community can use. One tool that we are working on is to ingest a lot of the unstructured data that you find in incident platform and do a burnout detector. So see if someone is burned out because they worked in too many incidents with a lot of severity for too long time. And also we are working on a project to create a graph of your incidents and infrastructure and see if we can see correlation. Let's say this part of your infrastructure is prone to instability, or perhaps this type of incident is often recurring. And all of this can be easily done using LLM to ingest all of this unstructured data. I think one of the key learnings that we've seen so far is that LLMs are like what it stands for is it's all about natural language, right? So I think they are really good at ingesting unstructured data. I think historically we've built systems that can only ingest like computer-generated data that are deterministic. But I think here the non-deterministic part of the system is what makes them so powerful, but also such a new thing. And that's why, you went from being a skeptic because of all this hallucination. But then when you manage to harness or understand how you can guide the system, you cannot dictate it, but you can guide it, right? I think then you understand how you can unleash the power. So I think we are very early in the day of this technology, and there is so much to understand. And so I'm really excited to be alive for this.
Yeah, no, absolutely. So, Sevan, where can people test the Rootly AI? Is that possible already?
Yeah, absolutely. If you want to try our AI SRE, you go on rootly.com and you reach out to us here, or you can reach out to me at sylvain@rootly.com. If you want to try any of the prototypes that we built that are open source and free to use, you can go on labs.rootly.ai. And here you can find our GitHub page with all the project and benchmark and dataset that we produce, and you can use them, contribute to them, share comments.
Fantastic. Amazing. All right. If you want to test Kenyon, you just go to getkenyon.ai and you put yourself into the wait list, and we are accepting around 50 people a day. And then you can knock yourself out, very early version, keep that in mind. experimental, and we are then going to decide what to do with this next. We are very, very interested in all of your feedback. Sylvain, as we are, we know as much as you do, so we're all in this together, trying to figure our way around. And we very much appreciate any feedback we can get. So with that, Sylvain, thank you so much spending the time. Super cool. And I hope we speak again very, very soon. And in 2 weeks, we have again so much more learning. And then we will, I'm sure, get together in one of these things very soon again. So we're very grateful for your time, and good luck in Florida's heat.
Thank you,